Emperor penguins suffer dire consequences with the loss of sea ice in Antarctica, resulting in catastrophic breeding failure. In a certain area of Antarctica, emperor penguin colonies had an unparalleled lack of success in breeding when there was a complete absence of sea ice in 2022. This finding confirms previous forecasts that more than 90% of emperor penguin colonies will be on the brink of extinction by the conclusion of the century, based on the current trajectory of global warming. A recent report published in Communications, Earth and Environment by researchers from the British Antarctic Survey has revealed some concerning findings. According to the study, there is a strong likelihood that no emperor penguin chicks have survived in 4 out of the 5 known colonies in the central and eastern Bellingshausen Sea. The scientists arrived at this conclusion after analyzing satellite imagery that indicated a significant reduction in sea ice at the breeding grounds, well before the chicks would have had the chance to develop waterproof feathers. Emperor penguins rely heavily on stable sea ice that is firmly anchored to the shore, also known as land-fast ice, for the majority of the year. This period extends from the month of April through to January. After they have arrived at their selected breeding location, penguins lay their eggs during the harsh Antarctic winter, specifically during the months of May and June. Although the eggs hatch after a span of 65 days, the chicks do not fully develop their wings until summer, which is between the months of December and January. In December of 2022, it was observed that the extent of sea ice in Antarctica had reached the same all-time low as the previous year of 2021. The most significant decrease was noticed in the region of the Bellingshausen Sea, which is located to the west of the Antarctic Peninsula. In November 2022, there was a complete loss of sea ice in this area. Dr. Peter Fretwell, the primary author of the study, expressed his views by stating, "In our experience, it is unprecedented for emperor penguins to not successfully breed on such a large scale within a single breeding season. The reduction of sea ice in this particular area during the summer months of the Antarctic has greatly diminished the likelihood of any chicks that have been displaced to survive. It is a known fact that emperor penguins are at great risk in a climate that is progressively getting warmer. Based on current scientific research, it is apparent that instances of extreme sea ice loss such as this will become increasingly prevalent and widespread in the future." Over the past 4 years, Antarctica has experienced a significant decrease in its sea ice extents, as recorded by satellites over the course of 45 years. The 2 most recent years, 2021-22 and 2022-23, had the lowest sea ice extents on record. In the years between 2018 and 2022, partial or total loss of sea ice impacted 30% of the 62 known colonies of emperor penguins that reside in Antarctica. While it may be challenging to immediately attribute extreme weather seasons to climate change, it is expected that the current generation of climate models will predict a long-term decline in the extent of sea ice. In the past, emperor penguins have dealt with instances of sea ice reduction by relocating to areas that are more dependable the next year. Nevertheless, researchers caution that this method may not be effective if the loss of sea ice extends throughout an entire region, impacting their habitat. In the modern era, emperor penguin populations have never been subjected to widespread hunting, habitat destruction, overfishing, or any other form of human interference. Interestingly, climate change is the only significant factor that influences their population change, which is unusual for a vertebrate species. Unfortunately, recent studies have predicted that the emperor penguin population will be dramatically affected by climate change, particularly the loss of sea ice. These predictions are bleak, as they indicate that over 90% of colonies will be on the brink of extinction by the end of the current century, if the warming rates continue at their present pace. Using satellite imagery, researchers have discovered 5 colonies of penguins within the past 14 years. These colonies are located on Rothschild Island, Verde Inlet, Smiley Island, Bryan Peninsula, and Frogner Point. It has been observed that all 5 colonies display a pattern of returning to the same location every year for breeding purposes. However, there was one exception to this pattern when the colony at Bryan Peninsula experienced breeding failure in 2010. As of now, scientists have made it a habit to utilize satellite imaging in order to locate and track emperor penguin colonies. This is primarily due to the distinct contrast between the bird's guano, which is brown, and the surrounding ice and snow, which is white. To achieve this, the team relied on the European Commission's Copernicus Sentinel-2 satellite mission, which has been constantly keeping an eye on the region in Antarctica since 2018. In the last 7 years, the sea ice surrounding Antarctica has undergone a marked reduction. The satellite record, which spans 45 years, shows that by the end of December 2022, the extent of sea ice had reached its lowest point. The Bellingshausen Sea, where the penguin colonies in question are located, experienced a delay in the reformation of sea ice. It was not until late April 2023 that it began to reappear. In the years since, the discrepancy from the usual has only grown more pronounced. On the 20th of August 2023, the extent of sea ice had decreased by 2.2 million square kilometers, which is a significant difference compared to the median of 17.9 million square kilometers between 1981 and 2022. This surpasses the previous winter's recorded low of 17.1 million square kilometers. To put it into perspective, the area that is now absent amounts to a size greater than that of Greenland, or approximately 10 times that of the United Kingdom. According to BAS polar climate scientist Dr. Caroline Holmes, as of August 2023, the current sea ice extent in Antarctica is significantly lower than any previous recorded measurements for this time of year. Even during the season of freezing oceans, there are notable regions that remain predominantly ice-free, which is a remarkable occurrence. The fluctuations in sea ice extent from one year to another are associated with atmospheric patterns that occur naturally, such as El Niño Southern Oscillation, the intensity of the Southern Hemisphere jet stream, and low-pressure systems in specific regions. To determine the exact extent to which these phenomena and natural ocean variations are impacting current conditions, we will require several years of purposeful observations and modeling. Nevertheless, the decline in sea ice records and the warming of the subsurface Southern Ocean in recent times indicate a strong correlation with the exacerbation of these extremes due to human-induced global warming. According to climate models, there is a projected reduction in Antarctic sea ice due to current and anticipated human carbon dioxide emissions. A comment was made by Dr. Jeremy Wilkinson, who specializes in the physics of sea ice at BAS. The paper presents a striking revelation about how the loss of sea ice is linked to the destruction of ecosystems. Climate change is causing the rapid melting of sea ice, which is projected to be entirely absent from the Arctic region by the 2030 ES. In the Antarctic, the 4 lowest recorded sea ice extents have occurred since 2016, further emphasizing the alarming rate at which sea ice is disappearing. Humanity has reached another pivotal warning sign that cannot be ignored. It is imperative that politicians take immediate action to mitigate the detrimental effects of climate change. Time is running out, and there is no longer any room for delay. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.